Now I'm going to tell you a little more about this article about quadratic reciprocity. The guy refers to a couple of guys. Keplerian, okay? Now Keplerian is actually a reference to Johannes Kepler, who was some kind of German astronomer, and he was the guy who stated the basic laws of planetary motion. He lived between 1571 and 1630 AD. So that's where that reference comes from. And then this guy goes on to mention a Leonhard Euler, okay? And he was the son of somebody who had studied in the ministry, and this guy who gave birth to Leonhard Euler wanted Leonhard Euler to study ministerial work and become a minister himself. And one of his professors recognized that Leonhard Euler would be better off studying mathematics than trying to become a minister, and with a little persuasion, that's how he became a minister. I guess he was born in 1707 and died in 1783. So, yeah. You can read up on both of these guys. There's probably a lot of stuff that you'll probably want to know. But anyway, apparently the Keplerian method that is mentioned in this quadratic reciprocity is different than the teachings of Euler. And of course there's a guy named Lagrange and Laplace, and I may put that in my next video. Apparently Gauss, who was talking about this quadratic reciprocity in Disquisitiones Arithmeticae, decided that it would be best to discuss this as logical proofs. So he was trying to do a method that was very similar to what Euclid was doing in the Elements, and so therefore yada yada yada, and we can go on and on and on, but we're not going to. I'm going to stop this particular video right here and let you absorb all that information. If you want to comment on Lagrange and Laplace, you may do so right down here. At least you now know who Euler is, and you know what Johannes Kepler is, so you can kind of get an idea of what you're dealing with if you ever decide to read this article. Whew. Wow. Anyway, I will tell you more in my next video, so stay tuned.